So today I want to talk about the difference between our regular everyday variables and what we call random variables. And normally random variables are something that you see in intro to probability courses. But if you haven't taken probability yet and you're thinking, gee, what in the world is a random variable? Well, don't worry. This video is meant to be sort of introductory and doesn't really assume any previous probability knowledge. So with that said, let's dive into the main question here. And really, again, what we're after is, what is the difference between a so-called random variable and our usual everyday variable? So with our usual everyday variable, you might think of some x in a function f of x. So for example, say we have f of x is equal to x squared minus 100, where maybe x represents the number of tickets sold by some movie theater on some given day, and then f of x gives the movie theater's net profit on that given day. So the important thing to note here is that in the equation above, we can plug in any x value that we want. We're not really trying to predict how many tickets the movie theater is going to sell or anything like that. We simply have a model for the net profit of the movie theater, and we're saying, okay, well, if the movie theater sells, I don't know, 10 movie tickets in that particular day, well, then its net profit is, 10 squared minus 100, so 0. So then the movie theater breaks even that day. But again, we're just plugging in any x value that we want. We're not trying to predict how many tickets the movie theater will sell. So by contrast, let's try to explore random variables. And so let's say that we're interested in some sort of quantity that has some degree of uncertainty. Say, for example, we're trying to find out the number of points that our boy LeBron James is going to score in his next game. And let's represent this number by capital X. And then so we're going to let capital X represent the number of points that LeBron will score in his next game. And to keep things simple, we're going to say somehow that we know that he will either score 20 points, 30 points, or 40 points next game, and say we have the following information. So let's say that we have these three different scenarios. So in the first scenario, let's say if LeBron James wakes up on game day and he eats Taco Bell's Crunchwrap Supreme, he will score 20 points. Let's say we know that for simplicity. Option 2 is he wakes up and for breakfast he has some IHOP pancakes. And let's say that we know if that happens he's going to score 30 points. Then lastly, if he eats some fancy omelet, made by his personal chef, then he'll drop 40 points on his next game. So these are our three scenarios. So now, if we model LeBron's points in his next game as a function of his breakfast, and here B denotes the type of breakfast that he had, we have the following scenario. So we have that when he eats the Taco Bell's Crunchwrap Supreme, he's going to score 20 points. When he eats the IHOP pancakes, he's going to score 30. And when he eats his fancy omelet, he's going to score 40. But we said earlier that x represented how many points LeBron would score, and we see that f of b also represents that same information. So f of b and x are really one and the same. But what does that tell us then? F is a function, right? And then so somehow that must mean that x is also a function. And it must be a function of b, the breakfast that LeBron eats on that particular day. And then so really we see that although we're calling x a random variable, it actually acts more as a function. So if we were taking some formal probability course, we could write that out symbolically in the following way. We could say that we have some function x that takes us from some set omega, which we're going to call the domain of the function. And so our function x takes us from the domain omega to some set e, where really here our set e is the set of 20, 30, and 40, because these represent the different outcomes for LeBron's total points scored in the next game. So for example, the function x takes this input right here and sends it, or I guess spits out the following value, right? So if I evaluate the function x at this value right here, notice that these inputs don't necessarily have to be numbers, right? We're just taking one input from one set and then plugging it into our function x, and it's spitting out some sort of value. So again, if we plug this value in for x, we get the following output, and then if we plug in this value for x, we get the following output. So if this seemed a bit abstract, you could also represent this in the following way. So we can write x as some sort of piecewise function, right? And it's specifically a function of b, where the value of x is 20 if b is equal to this input right here. The output is 30 if b is equal to this, and the output is 40 if b is equal to this. So tackling the question then of interpreting this piece of notation right here, right? So the probability that capital X is equal to some little x. How do we interpret that? Well, say there's a 20% chance that LeBron eats the Crunchwrap Supreme, a 30% chance that he eats the IHOP pancakes, and a 50% chance that he eats the omelet. What this tells us is that the probability that capital X is equal to 20 is 1/5. And why is this? So when is x equal to 20? Well, x is equal to 20, if we look back up here, x is equal to 20 when b is equal to this input right here, right? But we're told that the probability of LeBron eating the Crunchwrap Supreme is 20%, right? Which we can write as 1/5. Similarly, the probability that x is equal to 30, right, is equal to 3/10 because the probability that LeBron eats the IHOP pancakes is 30%. And likewise, we can do the same thing for the probability that x is equal to 40. So while this notation initially looks a little bit ambiguous, you have this probability of capital X being equal to little x, and you're not exactly sure if there's a distinction between the two. It's important to keep in mind that this capital X is really just a function, and then this little x is some input that we're specifying. In the case of the piecewise function notation, it's these values right here. And so there you have it. That's our introduction to random variables.